Hi, good morning. I would imagine most of you sat there thought that when you left school, you were never going to have to sit and listen to another boring teacher again. I apologise. I'm going to try not to be too boring and give you my views on where I think 3D printing can be used in education. Just to put this into context, the Windsor Boys' School. I think when I say that, a lot of people get the wrong idea that we're some rich private school and that 3D printing is easy to implement there because we have funds and education which is suited to this. We're not. We're a fully comprehensive state school. Upper school, 13 to 18-year-old boys. And as you can see at the bottom, only 20% of our intake every year would be classified as being a high prior attainer. So we're dealing with all ends of the spectrum. Yes, we have boys who go to Oxbridge, but the vast majority of our pupils who come in are not at that level. A little bit about me. The only surprising thing about that is that I've been teaching for 17 years. Most people last about 17 minutes these days. You can read more about that on the website. I'm going to quickly move on. There are some companies that I've worked with, so hopefully my credentials, you can see I've worked with some decent people in the 3D printing industry, Department for Education and Data being two big ones in the UK. Last week, I had the privilege of talking with Megabot and Stratasys at a conference where they were talking about Industry 4.0. And they were very excited about AI, AM, VR, anything with an acronym they got very excited about. And they were really, they were confused as to why education was not keeping up. They were surprised that we were lagging so far behind. And they basically wanted to know, well, why is 3D printing not making it into the classroom? What is preventing this wonderful tool, this wonderful educational tool from getting in there and getting the kids using it? And I think, and this is where it gets a little bit depressing for the next 5 minutes, I think there are three main barriers to getting 3D printing into education. I don't know if anyone here knows who this chap is. Some people clearly do, that's why they're laughing. It really upsets me being this close to a 4-foot-tall picture of him. Michael Gove was our education minister 2010 onwards, and his belief was that all children should have a purely academic education system, sidelining all the creative subjects, drama, music, art, design and technology, photography. They all became secondary subjects. His view, or his vision, that we are implementing still in the UK, is that 90% of pupils going through school will do the EBAC curriculum by 2020. I find that extremely scary as an educator in a comprehensive school. The Arts Council also find it extremely scary as well. They issued this statement pointing out that all of this was completely unevidenced. It was bad for education. And especially when you consider there in bold that the creative industries contribute £90 billion of revenue to the UK. So in the future, where is that 90 billion going to be made up from if we go down the EBAC route? What made me even more scared, I seem to be getting very scared by this, were these figures. These are your creative subjects, and you can see the number drop since the sort of suggestion that we go down the EBAC route. And my subject that I'm very passionate about, design and technology, we've been hit the hardest. And this is the area where 3D printing is probably going to be used most in education. So our numbers, as you can see, have halved since 2010, and every year they're taking a 20,000 pupil hit per year. 5, 6, 7 years, is design and technology going to still be around in the UK? I'm not sure. Another barrier to 3D printing in education is funding. The government this year made a really big statement that they were pumping £1 billion extra cash into education, and the public bought it. They fell for it and thought, wow, that's great. But this year alone, there are 125,000 extra pupils in the education system. So in essence, we're operating at a loss, and we have been doing for a long time. D&T is an expensive subject, and considering when you think a 3D printer might cost around £2,000 and consumables, it is expensive to run for schools. My budget for the whole year across all areas of design and technology is only £2,500. So 3D printing, it doesn't seem like a sensible option when you have no money. And then finally, teachers themselves are the curriculum that we teach. This year, a new curriculum for design and technology came in. It was supposed to be an advancement on the old one into the bright new future. I dissected it. It's 60 pages in length. I stuck it on my whiteboard and stood back from it. And in all those 60 pages, there was nothing that said we had to deliver additive manufacturing or 3D printing in there. There was that we had to use a tenon saw and a hacksaw, but nowhere did it say we had to teach children about additive manufacturing. If you're going to be successful in getting this in, you need a forward-thinking curriculum in place. So, away from the doom and gloom, how did we get into it, and where are we going with it, and where do I think the future is? We got into it in 2012 when the government invested 21 printers into school. In a population where there's 8.5 million pupils, 21 printers ain't a lot. So well done there. We had to bid for it. We were successful in our bid, and we took one home. We were given one of the earlier printers, the MakerBot Replicator, plywood thing. You can see it there, a lovely thing. We still have it. It still works. It's not been outmoded or outdated. It still does a job. And we got some training in CAD. There's one of our failures, and we had many of them. It's learning how to get over those failures so that you can get successes. And if you are going to put 3D printing into schools, this will happen. You just have to persevere. Getting to know the machines, getting to know their capabilities, and how to set them up is one thing. The picture on the left down there, I'm very proud of. I'm not a father. I don't like children. That's why I went into teaching. And I don't know what it's like to have a child put into my arms when it's born, but when that came off the printer, my first successful print, I sort of imagined it. I still have it. It's on my desk. I use it as a pen pot, but I'm very proud of it. This, out of all of my talk, is probably the most important thing that I'd like to get across to anyone who's thinking about education and 3D printing. My belief is that the printers aren't necessarily the problems. My belief is it's the making or the designing in the software that has to be overcome before we can print. There are sites like Thingiverse that MakerBot set up, which are brilliant starting points for infusing children at a low level. But as I say, you can get very quickly bored of printing Yoda heads. The novelty wears off. Children want to be creative. Children want to produce their own work. We spend a whole year, year 9, in the Windsor Boys' School, teaching kids how to use Autodesk Inventor till they become proficient and they can do wonderful outcomes which are additive manufacture ready. Some of our earlier prints, we got obsessed. Once we figured out how we do what we do, we became obsessed with printing big prints. They were spectacular. We'd show off with them. They had the wow factor. But actually, when we look back on them, they had very little learning impact at all. It didn't really affect the way in which children thought about design or the design process. They were just beautiful end outcomes. There are some more. And they are lovely, and parents on parents' evenings are wowed by them. They're really, really impressed by them. But we had to find a better way. We had to bring it further back in the design process and find a better way of using 3D printing than just printing pretty models. So, where do I think, and this is where we're currently at in the Windsor Boys' School, where do I think 3D printing lends itself best? The one good thing that the new curriculum's got right is it's put a lot of emphasis on the pupils going through the iterative design process. So prototyping, testing, evaluating, modifying, and repeating. And this, for me, is where 3D printing is the perfect tool for the job. Pupils, they can design something very quickly in the space of a lesson. They can send the STL file to me to be printed. It can print during the lesson, or it can print overnight. And for the next lesson, they will have a tangible physical outcome in their hands that they can then take to their client, or they can take into the environment where it would be used, and they can test it, thoroughly evaluate it, and they can go back to the drawing board and re-modify. Here are some examples of where we're now using this 3D printing technology lower down in the design process, so the iterative process. You can see very simple prototypes, very quickly mocked up, put into place to be tested and evaluated, leading to better design. Some more examples. Again, these are in year 10, so these are 14, 15-year-old boys doing these. Not only are we designing products that look nice, but we're also trying to get that mentality that inside something like a speaker dock, for example, there have to be internal component housings and mountings for the circuitry and the speakers to go. Again, 3D printing is fantastic for doing that. Complex parts can be printed, and it really pushes the understanding of that on with the pupils. Handles, very popular at the moment. Projects that the exam board release are things like portable speakers. So having handles and handle mechanisms are just one way in which we're going. More complex parts, different parts for angle poised lamps, for example, bottle top, screw top lids. You get the idea. Again, a lovely sheet produced by one of my pupils, 16 years old, figuring out how he was doing a pump dispenser for some hand cleaning fluid, internal components to get the fluid to flow around, 3D printed out. I think he did about 4, 5, 6 iterations of that before he got it right, but he would never have been able to do it without this technology. These are some of the benefits that you could say. So if you were trying to sell 3D printing in education and the head teacher or the teacher said, how are my pupils going to benefit? How is this any good? These are some of the things that we found out. And I think really important one at the bottom, I've put it at the bottom, I don't know why, for me it's really important, we are teaching them skills that make them applicable to go into the future world, into future industries that use this technology. It's about preparing your pupils for jobs that they are going to go into, not necessarily jobs that are available at the moment. A word of warning, a caution. People think as soon as you bring a 3D printer into the classroom, you start producing outcomes like that automatically your school's results go up in that particular subject. They don't. There are no rewards for 3D printing because it's not actually written into the curriculum that you have to use it, so they don't give marks for it. It helps in the learning process, so this is where your learning comes. This is where the benefits of it come. They come in directly because it promotes an understanding of the processes which are integral in that design process. So you don't get any outright marks in our schemes of work in the United Kingdom for it, but all of that work earlier in the design process, that all adds to the marks at a later stage. So that's where we're at now. These are the two things that we're looking at for the future. So this is 5 years down the line from getting our first printer. We are looking at different material properties. We obviously can only print in polymer because we've only got desktop FDM printers. We're not fortunate enough to be able to afford the metal sintering printers or even the SLA printers where we grow things out of puddles of liquid polymer. So a couple of the examples there are really quite interesting, and the pupils have really taken them on board. Flexible polymers. So some boys in year 9, one of the first projects, they'll design phone cases, for example, for their iPhones. Having a flexible polymer is ideal for that. They can then customize them to be what they want. And the one on the right is a new filament that I was sent a few months ago, which saves a lot of time in post-processing, because believe me, when those models come off the printer, they don't look like the beautiful outcomes that you've seen. There's a lot of post-processing involved. There's a lot of being in a workshop, of sanding, of body filling, of spraying to get those outcomes. This particular polymer promises to save a lot of that time because when it's sort of exposed to an alcohol, it will take away those lines, those print lines that are laid down by the 3D printer and leave you with a shiny part that looks as if it was injection molded. Our next big plan is I'd love to say that the Windsor Boys School was going to open up a revenue stream and start earning some money back that's gone on the outlay of these printers by setting up a 3D hub. I already print a lot of parts for schools in inner city London that don't have the printers or the skills to do it. They send me an STL file. I'm more than happy to print them. It costs me maybe £3 or £4 in plastic every time I do a print. It's not a lot. But the idea of getting 3, 4, 5, 6 printers and setting up a hub is one that really excites me. Obviously, it will enable more pupils to have exposure to that, and of course, hopefully then bring the wider community into the school as well. Hobbyists and people who are intrigued in this technology can come in, they can try and do a print for themselves, and we can then print it for them. So, to finish, the last two things. If I was to surmise what I've just talked about, if I was to say what do I believe are the most important things in embedding 3D printing in education, I go back to this. The children have to be able to create. Getting teachers in place that are skilled in this technology, that have a background in CAD design, and can teach kids how to use this complex software in order to create the shapes that they want to print, I think is the most important part. If you can't create, you can't print, or you're printing someone else's work, and that is a pointless exercise. And to end on sort of an interesting, poignant note, if as teachers and future employers, we do nothing to educate children about this technology, which is going to play an important part in the rest of their lives, both at work and at home, then we are going to be failing them. It's simple. China are already ahead of us. They put 500,000 printers into their schools. We put 21. I'd say we're already failing them. We don't want to be there. We want to be at the front of this, not at the back of this. Okay? My contact details are there. I don't have business cards, unfortunately. I'm a teacher. So if you do want to contact me, drop me a line if you're interested and want to know more about this, then I'm more than happy to be involved. I'm very passionate about it, and I want to see it succeed wherever you have these things. And I cannot believe that a teacher has finished a minute earlier than he should have. Fantastic. Thank you.